Hello, and welcome to our first in a series on how to build your own operating system. The first and most logical question you have to ask yourself is, what is an operating system? And to put it simply, an operating system is the set of files and the set of procedures that your computer goes through to perform any task. It allows you, the operating system is what allows you to connect to your printer, the internet. It's what allows you to have any sort of downloading onto your computer. Any and all basic functionality or protocol or connecting to a peripheral device is done through the operating system. And operating systems are built on top of computer architectures. Now, there are quite a few computer architectures, but the most common one is outlined here. We have over here the motherboard. Now, the motherboard is the very first thing in your computer to boot up, because the motherboard has what are called BIOS files. And BIOS files are the first set of instructions that are given to your CPU that tell it how to boot itself up, that tell you how to access the operating system. But the BIOS files have to be generic. And because they have to be generic, and by generic I just mean common across any operating system that you might want to install. Let's say you buy a computer and you want to install Linux or Windows or OS X, right? The BIOS files have to be able to support accessing any of those operating systems. And the difficulty is each of those operating systems installed to a different location over here on your hard drive. I know you probably can't tell, but that is an H. We'll just HD. Jeez. It's really hard to draw on this thing. HD. So that's the hard drive. And the hard drive is where your operating system is stored for the long term. But it's always going to store it in a different place, or maybe it doesn't, but it can. So your BIOS can't tell your CPU where on your hard drive your operating system lives. But it can tell your CPU where on your hard drive a program called the bootloader lives. And the bootloader is what's going to tell your CPU where on the hard drive your operating system kernel lives. So let's dig into this a little bit. So let's go back and we'll start at the motherboard. And the BIOS files are copied. They're copied over to the RAM here. And the RAM is just, think of it as short-term memory. Or if your hard drive is a cruise ship, this is the dinghy, right? It's constantly being overwritten with new instructions. So the motherboard tells the CPU, the motherboard writes its BIOS to the RAM, and then tells the CPU, hey, go look in the RAM. And that's what these pointers are for. The CPU is a set of registers and two very important pointers. And these pointers are going to be set to point at this value, the first value of our BIOS file. And all our BIOS files, well, our BIOS file might do more than this, but one of the main functions for our BIOS file is telling the CPU, hey, look here on the hard drive for the bootloader. That's all they're doing. That's most of their functionality in a nutshell, telling the CPU, look here for the bootloader. So the CPU comes here and asks the question, hey, where's the bootloader? And the RAM tells it the bootloader is in the hard drive at partition 1 or partition 3 or partition 4, right? So then the CPU goes to the hard drive and it says, hey, I want you to write the information that is on partition 1 or partition 2 or partition 4 or whatever partition it gets from this memory, and I want you to take what's in that partition and write it to the RAM. So the hard drive says, well, alright, I can do that, and it writes the contents of that partition, which are the bootloader, to this segment of RAM. And now the bootloader has information. The bootloader, because it's in the hard drive, is stored in memory. It's not like the BIOS that live on the motherboard, right? That are more hard. They're more hardwired into the computer. The hard drive has I guess you could say softer memory. The hard drive can be overwritten. These BIOS files cannot be, well, they can, but for our purposes, they can't be overwritten. They are they are almost hardware. They are files, they are programs that should be thought of as hardware. But the hard drive can be overwritten. So that's why we have the bootloader that lives on the hard drive. Because it provides the information about where different operating systems are. So you have this information about where different operating systems are written onto the RAM. And then these pointers get set to look at this position. This first instruction in the bootloader. And they're asking, all right, where in the hard drive should I look next for the operating system? And then it tells it, look in partition 2, or partition 3, or partition 18, right? Probably not partition 18, but maybe, right? Partition whatever is where the operating system that we want to use lives. So the CPU, alright, Mr. Hard Drive, or Miss Hard Drive, or MX Hard Drive, write the contents of the partition given by the bootloader to the RAM. So the hard drive comes down here and says, alright, well, we're going to write it over to this segment of RAM. And this is your operating system kernel. It's the kernel file for the operating system. And whenever you hear kernel of an operating system, I want you to think of it like a seed. It's the seed that your operating system grows out of. And then your CPU the pointers switch to look at this segment of the RAM. Right there, the first instruction in your kernel file. And from there, your operating system grows. So, to review, we start on the motherboard. The motherboard has BIOS files. It writes those BIOS files to the RAM. Then goes to the CPU, changes these pointers to look at this value right here. The first instruction in our BIOS, which tells the CPU where on the hard drive, and you don't even need to think of this in terms, it could be completely divorced from kernels and OSs and any of that. The motherboard writes files to RAM, then tells the CPU, look at this file. This file is telling the CPU where to look in the hard drive. The CPU then looks in the hard drive, tells the hard drive to write that to RAM, and then looks at the first instruction that is now written to the new RAM. The first new instruction that's written to RAM. And this instruction set is going to tell the CPU where to look in the hard drive for the kernel. And the CPU is going to say, hey, hard drive, write what's in this section of your memory to RAM so I can access it. And then the hard drive writes that to RAM. The CPU looks at it, and that's what tells the CPU all the information about your OS. That's what tells the CPU we're running Windows 10 today, or we're running Ubuntu today, or we're running Debian today, or we're running Unix today, or whatever OS that you're running. Motherboard, BIOS to RAM. CPU looks at the RAM, goes to that location on the hard drive. Hard drive writes the bootloader to RAM. CPU looks at the bootloader. It tells it to look in a different location on the hard drive. The hard drive writes that location to RAM. That location contains the kernel. The CPU looks at the kernel, and the kernel contains the information about your operating system. Not simple, but understandable. It's a basis to work off of. It's a robust and a classic computer architecture that we could build off of. We still have some questions to answer. This kernel file, kernel, is still kind of a huge question mark. We understand what the BIOS files do. We understand what the bootloader does. But the kernel, there's still some questions, right? The kernel builds the OS. How does it do that? What files does it contain to do that? What information does it have to do that? What information does it need to do that? And this is what we'll look at in the next section. What does the kernel do? How does the kernel provide the information needed to build the operating system? That'll be part 2. Thank you, guys. Have a good night.